Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.47. While solving this problem, we will be using current divider rule. Basic equations for the calculation of currents I1 and I2 for this particular circuit using current divider rule is provided here. We also will be using equivalent resistance calculation formula for two parallel connected resistances. R equivalent is equal to the product of both parallel connected resistances divided by their sum. Now move towards the problem. Exercise problem number 2.47. Find I0 in given below figure. This is the circuit diagram of given problem. We have to find the value of current I0 inside this network. So for the calculation of current I0, we will use current divider rule. But before using that current divider rule, we have to minimize this circuit. We know that current divider rule implementation is easy for two parallel connected resistances. But when number of parallel resistances increase, the complexity of current divider rule is also increased. So I do not recommend you to use current divider rule for a network that includes more than two parallel resistances. In this case, we are only interested to calculate the value of current inside this branch. So we can merge these two parallel resistances together and find their equivalent resistance that can be replaced by these two resistances. Later on, we will be able to apply current divider rule inside this network to calculate the current of this branch. For the calculation of these two parallel connected resistances, we will use this formula, that is R equivalent equal to the product of both resistances divided by their sum. In this formula, R1 is 6 kilo ohm and R2 is 3 kilo ohm. So place the values inside this formula. Product of both resistances divided by their sum. Product of 6K and 3K will become 18K and sum of 6K and 3K will become 9K. Now divide 18K on 9K, the answer will be 2 kilo ohm. So we can replace these two parallel connected resistances with a single resistance that have the value of 2 kilo ohm. So modify the circuit according to the calculated value of R equivalent. Now inside this network we have two parallel connected resistances, so we can apply current divider rule. Before using current divider rule, we will label the branch currents. I am assuming this branch current is I1 and this branch current is I2. Now we will use current divider rule to calculate the value of current I1. For that purpose, the equation of current I1 will be equal to R2 divided by R1 plus R2 multiplied by I into T. Here I into T is total supplied current, R2 is the opposite branch resistance and R1 is the same branch resistance. In this case, both resistances are 2 kilo ohm and supplied current is 12 milliampere. I0 is equal to 2K divided by 2K plus 2K multiplied by 12 milliampere. Here instead of I1, I have taken I0 because we are interested to calculate the value of I0, that is equal to I1. Now solve this equation. Take the sum of both resistances. The equation will become 2K divided by 4K multiplied by 12 milliampere. Now this 4K will cancel out with 2K. The equation will become I0 is equal to 1 divided by 2 multiplied by 12 milliampere. Now divide 12 milliampere on 2. The value of I0 will become 6 milliampere. So the value of current I0 inside this branch is 6 milliampere. This was exercise problem number 2.47. Thank you. See you again in next video.